The data from the National Wildlife Strike Database has been uploaded into the visual analytics tool Tableau. The initial view shows all of our dimensions from the dataset in this window here. Dimensions include things like the airport, aircraft type, damage to the plane, incident date, and operator. Measures are also extracted and include numerical fields in the data like height and speed. The main window in Tableau contains shelves such as columns, rows, filters, color, and size. Tableau employs an interactive drag and drop interface where you can select dimensions and measures and drop them on the shelf. One of the things we wanted to visualize was the kinetic energy of bird strikes. In many cases, the National Wildlife Strike Database contains the speed of the aircraft and the species of the birds struck. Using a species lookup table for the average weight of birds, an approximate value for kinetic energy of the strike could be calculated using Tableau's calculated fields. In order to visualize kinetic energy in a useful way, we mapped it onto the flight envelope. Tableau also has the ability to suggest visualizations for your data based on the data type, saving some of the initial work. Selecting the field of height and the field of speed and clicking Show Me results in a suggestion to use a scatter plot. Once we tell Tableau to treat height and speed as dimensions, we are presented with a visualization of strikes in the flight envelope. Speed of the airplane is shown along the x-axis and height along the y, with each individual dot representing a single bird strike. We can immediately infer where in the air and at what speed strikes are occurring from the visualization. Dropping the calculated field of kinetic energy onto the size shelf affects the size of the dots. Here, larger dots represent more kinetic energy involved in the strike. At any time, we can mouse over one of the dots to see more information. The interaction with the visualization is part of what makes this tool so powerful. What are the high kinetic energy strikes at zero height? By mousing over the large dots, we see that they are wildlife strikes such as deer, elk, and cattle. For the purposes of our analysis, we were interested in strikes to commercial airplanes only. Tableau allows you to create groups and sets, which we did for Boeing airplanes, Airbus airplanes, and everyone else. Once the group has been created, we used it as a filter. By simply checking the boxes we are interested in, the visualization can be updated to only show Boeing and Airbus planes. We initially utilized the color shelf for species of bird involved in the strike. Dropping species on the color shelf assigns a color to each species and then to each dot. The species are listed on the right here. However, this is a bit overwhelming, so we narrowed down our search further using the FAA's Most Wanted list. Creating a group for the Most Wanted list the same way a group was created for the Boeing and Airbus planes allows us to filter the data. Dropping the Most Wanted list onto the color shelf results in a much more manageable visualization. There seems to be an abundance of one particular color dominating the display. Orange. Looking at our color key on the right, we see that orange is our good friend, the Canada goose. Canada geese are large birds, and strikes with them have a significant amount of kinetic energy. This is immediately obvious from the visualization. From here, we can look at the highest speed collisions by kinetic energy just by mousing over the dots in the display. We were also interested in visualizing damage. Changing color to represent damage rather than species is as easy as dragging and dropping the field onto color. Now, dots that are red are planes that have been destroyed, pink are substantial, orange major, turquoise are uncertain, and green have no damage. There only appears to be one plane that was destroyed, and mousing over reveals that it was the US Airways flight we are all familiar with. This visualization allows us to begin with the most damaging strikes and get a sense of where they are occurring. We were asked to do this type of analysis for radome strikes that have been damaging the ILS localizer antenna. By making a quick filter for damage to the radome, we can check only those records where the radome was damaged and then see the results. Mousing over high kinetic energy radome strikes led us to find some of the most damaging strikes in just seconds, as opposed to having to read all of the individual reports. In addition to kinetic energy, we used Tableau to look at geographic distribution of strikes by species. The size of the pie chart represents the total number of strikes at that airport, and the size of the slice is the percentage of strikes from one particular species. Again, this has been filtered to the FAA's Most Wanted list. One important thing to note is that not all records in this dataset contain species and airport location, so the ratios are not always perfect. However, it's rare that we will ever have an entirely correct dataset, and this gives us a good estimation of the actual ratios. Combining geographic location with time of day, we can see the number of strikes at different points during the day. The size of the dot is representative of the total strikes of Canada geese at that airport. Each map represents a different time of day: dawn, day, dusk, and night. Here we see that there are still a significant number of strikes at night, contrary to what some flight crews believe. This visualization shows both seasonal and temporal fluctuations in number of strikes. The height of each bar shows the number of strikes in each month, and it is colored by time of day. One interesting thing from this visualization is that in October, nighttime strikes actually outnumber daytime strikes, shown by the larger blue bar. This visualization could easily be filtered more, looking at specific airports, regions, or even locations of strikes on the plane. This video has shown only a few of the potential applications of this tool using the National Wildlife Strike Database. We have also played around with things like struck versus damage ratios for different parts of the plane, as well as the rate of strikes based on factors like wide-body and narrow-body aircraft. To sum up, the ease of interacting with data and visualizations makes this tool a powerful addition to any bird strike analysis.